Alright, so I'm Alex Lutzenberger, and this is my 15300 presentation, or 5-minute oral report on my research project, and I titled it Towards a Differentiable Knowledge Base. And so I'll start with who I'll be working with, and that will be Professor Zico Coulter and one of his graduate students. Professor Coulter has an appointment in the computer science department as well as the machine learning department. He works on a variety of topics, including low power computation, explainable architectures and for machine learning, and he has a research program in differentiable modules for deep neural networks. And so I'll start with what is a knowledge base, since that will be the topic of this. And knowledge bases are basically ontologies of facts represented in some logical form, so together they form an ontology, and they have knowledge. They represent knowledge about the relations between things and what they are. And so on the right I have a figure from the Never-Ending Language Learner, which is a CMU project that is also working in the areas of knowledge bases, and it here has an illustration of some of the facts and relations that it learned. So why differentiable? And so there are a number of advantages to the architecture being differentiable, which is the primary goal of this project, is to make these sort of existing frameworks or methods for doing things differentiable, and that allows fine-tuning to be done on the specific task which it's being used for. So you can imagine different tasks require different sorts of ontologies for which perhaps different rules in learning the ontologies might apply. It can be integrated into end-to-end architecture, so it can be differentiated through, so that would allow it to be used as a module, and maybe something which is generating the source text and using the output in some way, which it might be desirable for it to be optimized for. And making things differentiable and utilizing end-to-end neural network architectures, including those differentiable modules, has been very successful in the past. Perhaps most notably in speech recognition, but also in a few other things done in Professor Coulter's research program in the area. So in speech recognition, two of the papers that I did for my critique paper were on end-to-end neural network architectures for speech recognition, and one of them was Deep Speech 2, which is shown here, illustrated on the right, which, as you can see, is totally differentiable from the outputs of the network, the character representations or the probabilities of characters, to the spectrogram inputs, which basically visual representations of the Fourier transform of the speech data. And for years, speech recognition was dominated by models that at least included a hidden Markov model. But within the last half decade or so, we've seen end-to-end models really dominating the area, and being able to really utilize gains in performance from uh, faster parallel processors and improvements in deep learning. So, as I said before, Professor Coulter has a larger research program in differentiable modules, and this has included a differentiable physics engine, so actually being able to differentiate through some physical mechanics that occur, and a differentiable optimization layer. And so, why specifically a differentiable knowledge base? What's the broader importance? And there's been a topic of knowledge bases have been a topic of general interest to the AI community for a long time. They even have their own chapter in Russell Norvig, and they are important to a variety of AI agents, as you can imagine, having some contextual knowledge of the world around them in some form that is easily utilizable. And since it is useful in this variety of applications, the benefit of having a differentiable knowledge base can be seen, for instance, in the possibility of doing fine-tuning for those specific applications. And so, what's hoped to be accomplished by this? And the goal ultimately is to create a differentiable knowledge base, and ideally that differentiable knowledge base would have performance which is competitive, or at least comparable, with current state-of-the-art methods for creating knowledge bases.